Hi everyone and welcome back to a new episode of BWD. Today we're gonna learn more about default arguments and some unexpected behavior you might encounter as a developer. A good point to start here is this exercise that was asked a few years ago during an interview. Let's suppose to code a function that adds a number to an existing list, and if no list is passed, then the number is added to a new empty list. Pretty easy, right? Let's check it out now in the window below. Let's start by adding a number like 3 to a list made of 1 and 2. And it works, great! Now let's give it another go, but this time without a list. And again, no surprise here, we get exactly what we would expect. But notice what happens if we give it another go. The list has 2 elements now, and if we try another time, there are even 3 ones now. So why is that? And where is the catch? Well, that's exactly what we're gonna learn today. If you're new to this channel or you're back watching this video, do not forget you can find timestamps in the video description below. And all the code that you're gonna see in this episode is available on GitHub, link in the video description below. And now, without further ado, let's get started. Alright, instead of jumping back to coding, let's go to the board. The key point to understand the weird output we just saw is first to understand the difference between mutable and immutable data types. But even before that is to understand the difference between import time and runtime. Let's take as an example the function that we just saw. What happens in practice is that when you import a function in your program, Python doesn't execute the function. In fact, we have just imported. But what Python will do right away is to evaluate the function default arguments. And this is happening exactly when you import a function. That's why we say at the import time. On the other hand, when you call the function, Python will evaluate and execute the code found in the body. And that happens when the program is running. That's why we call this at runtime. So now you may ask, but what does evaluated actually mean? And why is this runtime versus import time thing relevant? Evaluated means that memory is allocated and filled with some values. So in the case of default arguments, this means that slots of memory are reserved to each default argument you might have in your function, and the memory is filled with their default values. Okay, so is that it? Well, this is relevant because default arguments are not evaluated anymore throughout the whole life of your Python program. So if their values are changed, then they are kept in memory for the entire life of your program. So you better not change them, otherwise you might end up with unexpected results like we've just seen with our function. So now some of you might say, okay, but I never changed a default argument, why should I? And someone else might also ask, but is this even possible? Well, the answer is yes, that happens, even if you don't do that intentionally. That's because default arguments have default values. And each value has a data type in Python. Data types can be either mutable or immutable, and this is the catch. But to better understand this, let's go back to coding now. Let's run again the code in the window below. And first off, let's check the values for the default argument. We can do this by calling the dunder attributes defaults over the append function. And as we can see, we get an empty list. And since there is only one default argument, in the append function, that's the default value for the ls argument. Okay, now let's try to call the append function and pass a value to ls. We get the output we would expect. And now let's check the default value for ls. What would you expect this to be? Well, since we pass a list to ls, we cannot have changed its default value, right? And indeed we can see that it's still an empty list. Let's try now without passing a list. We get the output we would expect, but if we check the default value, we can see now that it has changed. And if we call append one more time, we can see this has changed again. So now you may ask, but how can we change ls? Well, we did it. Let me show you. Let's define a variable called L and assign to it an empty list. Next, let's call the id function. id is a built-in function which returns the id of the memory, allocated to a value assigned to a variable, in our case L. Then, if we append an element to L, we have modified it. In fact, we can check its content now, and we see it is not an empty list anymore, but it has a 1. This 1 is kept in memory, and if we call the id function once again, we can see that this has not changed, meaning that the slots of memory assigned to all the value of L are still the same. And this is exactly what is happening in the body of our function, right? But now you might say, yeah, we have modified ls, but when I call the function again, ls must be an empty list, because that's its default value, right? But that is wrong. As we've seen at the board, default arguments are not evaluated at runtime, but at import time. That's why ls is not an empty list anymore, after we have modified it in the body of the function. So as you can see from this simple but yet relevant example, the list has been modified. And this is the result of two things. First, default values are evaluated at import time. And second, the default value here is mutable. So let me repeat this once again. This is not just because default values are evaluated at import time, or because of mutable default values. Both conditions must be met. In fact, let me show you what happens if we use an immutable value and we try to change it. Let's define a variable a and assign to it a string a. Now let's check its memory address. Okay, now let's try to change it by replacing a with b. So now what happens if we call the id function over a again? As you can see, the memory address has changed. But why is that? Well, that's because strings in Python are immutable. So when we change a, what is happening under the hood is that the new slot of memory is allocated to hold the new value for the variable a, and the slot of memory holding the previous value is deleted. However, in the case of a default value, the memory address is not deleted. And again, this is due to the fact that this function might still be used by the program, and that's why Python does not delete it. Let's see this in practice with another function now. Let's define add prefix, which is gonna take a sentence as an input and assign to it a prefix, which by default will be blah blah blah. Now in the body function, let's simply add a sentence to the prefix. So like this we are changing it. And finally, let's return it. Great. Now first, let's check the default value. As you can see, we got blah blah blah. Then let's call it passing the hello world sentence. Great, and now let's check the default value once again. As you can see, it has not changed, and that's because the default value, even if it is evaluated at import time, it is mutable, not like the empty list. However, in the case of a default value, the memory address is not deleted. And again, this is due to the fact that this function might still be used by the program, and that's why Python does not delete it. To make sure we have understood this, let's add a few print statements to the function to check the memory ID of the prefix variable. As we can see, the first print statement displayed a value which is different from the value displayed by the second one. And notice what happens if we call the function again. The first ID has not changed, whereas the second one has. So, why is that? Again, the default value is not deleted by Python when we change the prefix variable, but instead it is kept in memory. So every time we call the function, the value found in the prefix is always going to be the default value found in these slots in the memory. Great! Now let's double check this also with the append function. We code it up here. So let's add a print statement. Now let's check the default value. Okay, and now let's call the function. The memory address is displayed. Let's check the default value. As you can see, this has changed. And now let's call the function once again. As you can see, the memory address is still the same, but in the output we don't have one, but rather two ones. And again, that's because the default value is a list, which is mutable. Great! Now that we have understood what the problem is, let's see how we can fix this. Let's code another function. We're gonna call it pythonic append. And let's change the default value for ls to none. Why is that? Well, because none is immutable. This is why we are sure that we cannot mess up with it. Then, right below, we're gonna check if ls is none, then we're gonna assign it an empty list. Notice that this code is gonna be executed at runtime and not at import time. Then, let's append the number to ls. Great, now let's also add a few print statements to check the memory address before and after the if statement. Alright, let's start by checking the values of the default arguments. As you can see, now we get none. Let's call the function, passing a value to ls. As you can see, the memory address is identical. And that makes sense, right? Even if we add 3 to the list, lists are mutable, so the content of the memory is changed, but not its address. And if we check the default values, we still get none. Now let's give it a go without passing a list. As you can see, the memory addresses are different this time. But this makes total sense, because we are changing the content of the ls variable. But because its default value is none, which is immutable, when we assign to ls an empty list, this is saved in a different slot of memory. And as we can see, the default value did not change. And if you try to call the function once again, we get the same output, and not a list with an increasing number of elements. Great, now I want to show you another example, because you might think this problem is related to functions only, but that's not the case. For example, let's define a class called exam, and let's define the default attribute grades, and assign to it an empty dictionary. Then let's call the init method. We're gonna get the name and the exam date. Now let's define the math exam. If we check the content of the grade attribute, we get an empty dictionary. Let's say that BWD got a 10 as a grade, and if we check the grades now, we can see the new value. Great, let's define another exam. We're gonna go with chemistry. What's inside the grades attribute now? As you can see, we get the grade we have just added, and this again is because default attributes are evaluated at import time. And here we have assigned a dictionary as a default value, which is a mutable data type in Python. Okay, so let's see how to fix this. We're gonna simply move grades into the init method. And now, as you can see, if we define the math exam and then assign a grade to it, this has no effect on another exam that we can define later on. Great, so I hope you learned something new today. For questions and doubts, don't be shy and ask them in the comment section below. And with that said, do not forget to subscribe, and see you in the next one. Ciao!